Okay, we're going to go through section 3.2 on solving systems of equations graphically. Whoops, that didn't work very well. Hang on. Do that. 3-2. On solving systems of inequalities. Okay, so they're going to have less than, greater than symbols. Okay, and we're going to go through two examples. Okay, and usually in the directions it will say solve the system of inequalities. As soon as they say inequalities, then you know your boundaries are going to be solid. If they have less than or equal to, greater than or equal to symbols, it's going to be a solid line. If they have greater than, less than symbols, it's going to be a dashed boundary. Okay, so you have to keep that in mind when you're graphing these. Okay, so solve the system of inequalities by graphing. The first inequality is y is greater than or equal to 2x minus 3. Y is greater than or equal to 2x minus 3. And the second one is y is less than negative x plus 2. Y is less than negative x plus 2. So right now I can tell I have one solid boundary. The first one and the second one is going to be dashed. Okay, so let's graph this first one. It's going to go through at negative 3, the y-intercept, using y equals mx plus b. You can use it if you want to. You don't need to. Not for the notes. And then rise over run, 2 over 1. So go up 2 in the right one, up 2, right 1. Do that enough that you can see where your line is. Okay, once you get those, then connect those. And this one is a solid boundary because it's greater than or equal to. Okay, and then this is the part that some of you had trouble on the test. The easiest way to tell which side to shade is test 0, 0. And you can put it all the way back up into the original. But 0 is greater than or equal to 2 times 0 minus 3. So you get 0 is greater than or equal to negative 3. True or false? True. Shade that side. Okay. Shade that side. And for you, just use your pencil. Okay, shade that side. Okay. Okay, and then I'm going to choose a different color. Okay, and then we're going to graph this one. Graph y is less than negative x plus 2. It's going to be a dash boundary. It's going to go through at positive 2, so go up 2 and put a point. Slope is negative 1, so go down 1, right 1, down 1, right 1, down 1. Okay, enough that you see your line. And then dash it. There we're going. Dash boundary. Something like that, not solid. Okay, and then you test a point. The easiest point to test is 0, 0 on this side. You shade the side that's true. So if I test 0, 0, put 0 in, and you'd get 0 is less than, a negative 0 would just be 0 plus 2 is 2. 0 is less than 2? 0 is less than 2. That's true. Shade this side. Nope. Nope. Okay, and now the final answer is where it's cross-hatched, where it overlaps, and probably not a bad idea with your pencil. Just make this part a little bit darker where it's cross-hatched, or if you have a highlighter. Okay, so now that means any point in that cross-hatched section would work in both inequalities. Anything out in the other part would make one of them false. Okay, so where it's the overlap, okay, that's where it's true. Okay on that one? Okay, let's go to the next one. Okay, on this one, Okay, y is greater than or equal to a negative 3/4 x plus 1. And already I can tell my boundary is going to be solid line because of the equal sign. Y is greater than or equal to a negative 3/4 x plus 1. Okay, and the second one is y is less than or equal to negative 3/4 x minus, whoops, left off the x, negative 3/4 x minus 2. Okay, now, before you ever start, if those have the same slope, different y-intercepts, they are parallel. Okay, so we know we should end up with parallel. Okay, so let's look. Crosses at positive 1. Slope is negative 3/4. That's rise over run. So go down 3 to the right 4. Remember, anything that tilts in the negative direction should tilt this way. Okay, and you can go down 3 to the right 4, or from that point you can go up 3, left 4, up 3, left 4. Okay, and that's solid because it's equal. It's equal to, it's solid. Okay, put an arrow on both ends because it is a line. Test 0, 0. And notice where 0, 0 is on your graph. It's down below. So you get 0 is greater than or equal to 1. That is false. So we're going to shade the other side. Shade the side that's true. What's that? Okay. Okay, then do the other one. I'm going to do it in a different color. So this one, it crosses the y-axis at negative 2. Slope, same. Go down 3 to the right 4. Down 3 to the right 4. And you still always check to make sure, okay, this is a negative slope, so it should be tilting in this direction. And this is also solid. Okay, and now 0, 0 is on the top half of that graph, so test, put 0 in. Is 0 less than or equal to 0 times 3/4 is just 0. 0 minus 2 is 0 less than or equal to negative 2? No. Shade the side that's true, so I shade the other side. Okay? And your grader's got to know. So, is there any point of overlap? No. So for this one, there is no solution. Or some authors use the empty set. There's no point on this graph that would work in both inequalities at the same time. Okay? Okay, so that's basically what you're doing on the assignment for Monday. There will be a couple of problems, I think, where they give you 3 to graph. So you see where all 3 overlap. Okay? And if you want to use colored pencils on the graphing, if that helps you, I have some if you want to use them during the work time. Okay, but what I want to do right now is I want to go to a couple of columns out of the book. I need you to go to page 143 in your book. Number 59 first. 143, number 59. It's up at the top of the page. Okay, it says use a graphing calculator to solve each system of equations. Round the coordinates to the nearest. They want you to round to the nearest 100. Okay, and we've been doing everything pretty much by hand, like we did today. But I want to get you on the calculator also. So on number 59. It says 12y equals 5x minus 15. And then I have 4.2y plus 6.1x equals 11. Okay, and we're going to solve this on the calculator. We already know it's probably not going to be a nice neat integer because they're saying round to the nearest 100. First thing I would do is I would take this. To get it in on the calculator, you have to divide and get y by itself. Okay? So, and that's a polynomial. This is a polynomial over a monomial. So split that up. That 12 divides into both of them. So we'd have 5/12 x minus 15/12. Reduce that. 5/4. 3 goes into both of them. Good with that? Okay, now on the calculator, we're going to put this in parentheses. So on your calculator in the first, go to your mode and just have all of them highlighted on the front. Just okay. And then second function quit takes you back to the home screen. Go to y equals. Okay, y equals is in the upper left hand corner. Okay, and then do parentheses right above the 8. There's a parentheses key. 5 divided by 12. Close the parentheses, and then use the xt theta n key. It's the xt theta n. It's right here. Okay. 5/12 x minus, and then parentheses 5 divided by 4. Okay. And for what we're going to do right now, for the window I'm just going to choose zoom standard to start, and that's zoom standard is on the graph paper. It's -10 to 10 and -10 to 10. That's your standard viewing window. Zoom decimal is a smaller user-friendly window, but if you go on that top row and just do zoom, and it's zoom 6 for zoom standard. Okay, and it should show you a graph of a line. Should be coming through similar to this on your calculator. Everybody get a graph? Anybody need help? Okay, so now we're going to go to the next one. First, if that bothers you to have the decimals in there, what could you multiply by? 10, right? Because we got one decimal place. So we could multiply this whole thing by 10 if we want to avoid. Okay, so this would just be 42y plus 61x equals 110, right? You agree with that? Okay, subtract the 61x. Basically, all I'm doing is trying to get y by itself. 42y equals a -61x plus 110. Divide by 42. And y equals, and that's a polynomial over a monomial, so that'd be a -61x over 42. And you can put that x out at the side if you want to. And then plus, and you could reduce that, or I can choose not to reduce it. Okay? Okay? Now if I ask you for an answer on the homework, yes, I want it reduced. Or on the test, yes, I want it reduced. But for what we're doing right now, okay? Okay, so on your calculator, go to y equals, go down, get your cursor down right by the equal sign on y sub 2. And then we're going to put in that equation. So let's go parentheses, a -61 divided by 42, close the parentheses, x plus parentheses 110 divided by 42, close the parentheses. Okay, everybody get that in? Okay, and then hit graph. Everybody good? Hit graph. Okay. Okay, and you should see another line come through similar to that. Close. Okay. It is not a nice, neat integer. Okay. And we want to find that point of intersection. So right above the trace key, up here on the top row, right above the trace key, do second function calculate. And number 5 is intersect. So just press 5. You can either down arrow, down arrow, down arrow, or just press the number 5. Okay? And mine, notice mine has the expression, the equation that I'm on, it has that up at the top. If yours does not have that, if it's not showing that, you can get it to show that under second function format, turn your expression on. I always like to see what equation I'm on. Anybody need help on that? Getting that to show up? Okay. The closer you get that point to the actual intersection, the less the calculator has to do. Okay, so use your right arrow or left arrow, wherever you're at. See, it's moving that cursor close. Get it close to that point of intersection and press enter. Okay, now notice my expression changed up at the top to the second equation. It's asking for the second curve. Press enter. It's asking for a guess. We did not calculate any guesses, and mathematicians are lazy. I don't know why they put that question on there. Press enter.
I know for a second.
Okay. Okay. Did you do second function calculate intersect? Okay, and our point, they said nearest, what did they say? Nearest 100th. So to the nearest 100th, the x value would be 2.07. And the y value, negative 0.39. Okay? Okay.
It won't like say 6 or it doesn't say the second.
Okay, let's try one more. Okay, this is number, that was the answer on the other one. Let's try number 61. Okay, it's 5.8x minus 6.3y equals 18. The other equation is negative 4.3x plus 8.8y equals 32. And I could work it with the decimals, but most of you don't like them, so we'll go ahead and get rid of them. So on this one, let's multiply by 10 because we have one decimal place. So we'd have 58x minus 63y equals 180. And I'm going to bring the y over to this side. Add 63y, and I'm going to subtract 180 over to this side. And I get 58x minus 180 equals 63y. Let me stop there. Do you agree with my arithmetic? Okay, divide by 63 to get y by itself. You got to get y by itself to put it in on the calculator. Okay, so we'd have 58 divided by 63 x minus 180 divided by 63 equals y. And for the calculator, we're going to put parentheses around those fractions. Okay, so to graph this, you go back to the y equals and just press the clear key and clear out those first two equations. Clear key's right here. Okay, clear those out. Get your cursor up on y sub 1 to start with. Okay, clear them out. Okay, and then put in parentheses 58 divided by 63, close the parentheses, x minus parentheses 180 divided by 63, close the parentheses. Okay, and I'm gonna start out, and there are times when you graph, like you could end up in Zoom Standard and maybe your graph's out here. Zoom Standard is just a starting place. If you ever, go to Zoom a minute, if you ever don't get a graph, put the trace key on and look at some points, but you can always, the higher you go in math, in calc there are a lot of times where the window is so far off of negative 10, that we need to use Zoom Fit. Zoom Fit will always start a graph. Doesn't give you the best window, but it always starts a graph. Or you can put the trace key on and look at the ordered pairs, and it tells you a little bit of how to set your window. Okay, so let's just do Zoom 6, Zoom Standard, and see if we get a graph. Yes. So on this one, we're getting a graph to show up kind of like this. Okay. So you should have a graph that looks like that. Let's go back now and graph this other one. Same thing, I'm going to get rid of the, so multiply by 10 on both sides. You don't have to, but, so it's a negative 43x plus 88y equals 320. I'm going to add 43x. And if some of you are at that stage where you can do that by sight, I'm okay with that. Put the x value first, then the 320, divide by 88, and y equals, so you'd have 43 over 88x plus 320 over 88. Okay, put parentheses around this. Okay, now let's go to y sub 2. You got to get your cursor right by the equal sign on y sub 2 and do parentheses. 43 divided by 88. Close the parentheses, and then an x. Okay, plus parentheses 320, and then divide by 88. Close the parentheses. Okay, so it should look like that on the overhead. Okay, and then graph it. Does that look like your graph? Okay, now that means the intersection point is off to the right. So which part of the window do we need to change? X max. So let's go to window on that top row and change your X max. Let's go to 20. Okay. And graph. Ooh, just about. So change your window. Let's go X max, what, maybe 30? Do we need to change the Y max? Maybe. Let's go up a little bit higher. Let's go to 20 on the Y max. So you can play with the window till you get a good point of intersection. Okay, now we're seeing it. And you guys, when I do this in Trig and in Calc, I usually write down my window in case I want to come back. 3 years later, you're at college and you want to graph this. You know, what I do is I say my X window is negative 10 to 30. I really don't care what the scale is, but if you want to write the scale, I usually write it up there. For the Y, my window, I did negative 10 to 20, and my Y scale was 1. And that way I know the other graph looks like this. Now let's do second function calculate right above the trace key. And number 5 for intersect. Okay, see where that puts my cursor? I could do it from there, but the closer I get it to the point of intersection, the less calculations the calculator has to do. Do second function calculate right above the trace key and number 5. Just press 5. Okay, and then get your cursor close to that point of intersection. It's on the first curve, press enter. It's on the second curve, press enter. Guess, press enter. Okay, so my X, my ordered pair on this one is nearest 100, 15.03, comma, 10.98. Okay, so that's my final answer. Okay, where did I put the other one? Here's the other final answer. Okay, so basically I wanted to get you in on the calculator. I will tell you this. If they ever give you 3 equations to graph, okay, you still can do a point of intersection, let's say, and maybe I have 2 equations that look like this, and then there's another equation that's up here, okay, and maybe I want this point of intersection. The calculator cycles through from like y sub 1 to y sub 2 to y sub 3. So if you did second function calculate intersect, it's going to put it, say it puts it on this first equation. You move it close, you get it to that point. And then this was the second equation, it jumps up here. It jumps. It cycles through that x value. So if there were 5 equations, it would cycle through up and down. That's not the right equation. So what do? Use an arrow key and get down to the other equation, okay, and then it figures that one. Okay, So if you have more than two equations, it cycles through all of them. So you got to make sure you're on. That's why it says first curve, and then you got to make sure you're on the right second curve. If you're not on the right second curve, you got to use your arrow key to get on the right second curve. Okay. Okay. Let's go back for a minute to section 3.1. Go all the way back to section 3.1. Okay. For example, problem number 1. The ones I just took you through were decimals. I wanted specifically to get ones that were not nice, neat integers. Go back to page 141, problem number 1. Y equals 3x minus 4, and y equals a negative 2x plus 11. Okay, let's do those and find the point of intersection. Okay, go back and clear out both equations. Okay, put in 3x minus 4. Then go down to y sub 2. Put in negative 2x plus 11. I had you do these by hand on the homework. Now I want to show you can do them on your calculator. Okay? Which means, probably on this next test, it's going to be in two parts. Part where you will have access to a calculator, part where you will not. Okay? So I do that a lot in my trig and calc classes. Okay, so do zoom standard, zoom 6. Okay, notice one is off. It actually crosses outside the window. Whoops. Oh, lost my page. Okay, so if you wanted to see where it crosses, because it crosses at plus 11, you'd have to change which value on the window. Does it show? Oh, what's your zoom standard? What's your window go to?
Let's see.
Because it should cross at 11, right?
It's just times for me. Yeah.
Okay, but it's actually crossing off the screen up there. Okay? Because doesn't it go through at 11?
What? Oh, it crosses the y-axis.
I'm just saying, where does it cross the y-axis?
Oh, yeah. It's up there.
The point of intersection's on the screen. Sorry, I wasn't communicating. Yeah, so if you needed to see, if they needed to show, and down the road you'll learn in upper level math that you show a complete graph. A complete graph means you show all the intercepts, and we're not seeing that one intercept, so we need to change the y max to maybe, let's go to maybe 15. Okay. Now you seeing all the lines cross? Yeah. Okay, now let's find the point of intersection. Do second function calculate, intersect. Okay, get that cursor close, use your right arrow. I'm using my right arrow key. Get it close to the point of intersection. Second, press enter. Second curve, notice it changes to the second curve. Press enter. Yes, press enter. I could put in a guess, but I don't want to. Okay, 3, 5 is the ordered pair where it intersects. Okay? Okay, so basically you put in both equations. You got to get it to y equals. Then what did we do? Second function calculate, intersect number 5. So you need to do enough notes. We did second function calculate, which is above which key? Trace. If it's a key, I usually circle it. So this probably should not be circled. Second function calculate, it's above the trace key, and then do number 5 for intersect. Get your cursor close to the point of intersection. You press enter. Second curve, press enter. Guess, press enter. So you're pressing enter 3 times. Okay? Everybody good with that? Okay. You need graph paper for this assignment, so make sure you have enough. Okay?